Welcome to my YouTube channel. Today we are going to talk about the electric potential energy and the electric potential energy difference. So these both are the different terms. There is a big difference about these two terms, and in this video we are going to talk about it. Okay. So first of all, we are going to talk about what is the electric potential energy. So we all know about the potential energy. So in easy way, we can define it as the potential energy of a unit positive charge. The electric field is called electric potential energy. So what it means, let me take you another page. Let's say I have these two plates. Okay, this is my positive plate. Okay, and this is my negative plate. So what will happen? The electric field will develop, and the electric field lines will move from the positive plate towards the negative plate. So they will be all around. I am not drawing in the middle because I have to draw a unit positive charge here. So I will draw a unit positive charge here plus, okay, it is my unit positive charge. Let's say it is a point A and this is a point B. Okay, so if I define the potential energy of this charge at point A, it means that it is the electric potential energy of the positive charge at this point A. Okay, so if I define the potential energy of point B at this point, then the potential energy of this charge will be called or known as the electric potential energy. Okay, or in easy way we can say it like that. Let's say this is my positive charge here. I will draw a positive charge. Okay, positive charge here. So what will happen, because this positive charge has a potential energy, so what will happen, this positive charge will automatically move towards the negative charge. Why? Because it has a lot of potential energy. But on the other hand, if I see this positive charge, can it move towards the positive charge? No, because its potential energy is very less. So in easy way we can define it as the potential energy of any charge of a unit positive charge in the electric field is called the electric field potential energy. Okay, we usually define it with letter U. So let's say I'm defining the potential energy at point A, then I will write it as UA. What is UA? UA is the potential energy of of the unit charge, this unit charge, at which point? At point A. Similarly, if this charge is at B, so what will its potential energy, electric potential energy, will be U subscript B. Okay, it defines the potential energy. Okay, so now moving towards our second definition, what it is electric potential energy difference. So what is electric potential energy difference? It is the work done to move a unit positive charge from point A to point B is equal to the potential, it is equal to the difference in potential energy at the 2 points. Okay, so I will explain it in the easy words. It is a definition. Okay, and in easy words, what is basically the potential difference. Okay, so let's say I have the charge at point A. So if I take it at point B, so what will happen, I will need some work. Okay, I will need some work to move this charge towards the point B. And what is this work? According to this definition, this work is equal to the difference in potential energy at the 2 points. So we will write to elaborate more. So let's say, according to this definition, if I try to move this charge from here to here, so what will happen, its potential energy will change from UA to UB. Okay, so it defined that the potential energy difference between these 2 points, okay, is equal to what, is equal to the work done. Which work? The work to move this positive charge to the point B. Okay, so according to the definition, according to the theory, the electric potential energy difference is equal to the work done in moving that in moving that charge from one point to the another point. Okay, so okay, so now moving forward. So one thing important, okay, I want to explain one thing here. So as we know that the electric field is what is a conservative field. So what is this? It is a conservative field. So what is meant by conservative? It means that if I take this charge, positive charge, to point B from point A, if I follow this path, if I follow this path, or if I follow this path, all of these paths will have the same work done. On easy way, we can say that the work done in the conservative field or the electric field is independent of the path followed. Okay, it means that we can follow any path, the work done will be equal. Okay, so remember one thing, very important thing, that for a conservative field the work done is always equal to the negative. Okay, so the work done here will be the negative W. Okay, so now moving forward, as we know that the electric potential difference, if I move my charge to point B from point A, so the electric potential difference will be equal to what? Will be equal to the work done, because the work done is in the conservative field. So that's why we will put a negative sign here, this negative sign. And we all know that the work done is equal to F force into the displacement D. Okay, so there will be again a negative charge. Okay, so as we know that we are working in the electric field, so our force is also electric force. Okay, and according to Coulomb's law, the electric force is always equal to K into Q into Q. Why Q1 not Q2? Because our charge is same. So in both cases we will take Q into Q divided by R square. Okay, why these are not q1 and q2? Because in the derivation of Coulomb's law we took two different charges, but in this case we are having the same charge and we are just moving it. Okay, so we will put the same charge here and the same charge here. So this is the force. Okay, so this is a force. After that, we all know that what that if I put it in this way. Okay, now putting it this way, let me again write it. Let me take this q out. So q into k into q over r square. So from our previous topic, we know that this expression is nothing but the electric field. So we can say that the electric force is equal to charge into electric field. So it is our derivation. I can call it equation number 1, and this is my equation number 2. So I will put now what I will put equation number 2 in equation number 1. I will put the value of force here. Okay. So now putting it, we can make our equation number 1 equal to, so the UB, the potential difference UB minus UA was basically equal to minus F into D. I am putting F is equal to Q into E. It will become minus Q into E into D. So this is what this is our final expression of what of potential, electric potential energy difference. So in short way we can say that the electric field potential energy difference is equal to Q into E into D. Okay, okay. So moving forward, what will be the unit of it? Okay, easy answer. What will be the unit? Because we know that it is energy. Okay, and the unit of the energy is Newton meter or joule. Okay, whether it is a difference, it is not a difference, it is energy. Okay, so we all know the energy, whether it is in the electric field or the gravitational field, its unit is same and it is joule. Okay, so now moving forward, I have example for you. Okay, so now making this example. So let me take two plates. Okay, there is one plate, okay, here, and there is another plate. Let me draw it again. There is another plate here. Okay, okay, there are two plates, and what is happening? It is my positive plate here. Okay, and this is my ground or negative plate here. Okay, so what will happen? The electric field lines will move from positive plate towards the negative plate in this form. In this form, they will also again in the middle, but I am not drawing it again. Okay, so let's say I have a charge here. It is a unit positive charge, or okay, it is a unit positive charge, or let's say I will say it is a negative charge. Okay, not taking the positive again and again, it is just a convention, so I am taking negative charge here. Okay, so this is a negative charge, and what is happening? It is my point A here. This is my point A, and here it is my point B. It is my point B. So what I am doing, I am moving this negative charge to the point from point A towards the point B. Okay. So my question to you is that at point A there is UA potential energy and point A there is UB potential energy. So which potential energy will be greater? Whether this charge will have higher potential energy at point A or at point B. Okay. So now listen this answer very carefully. So what I am doing, I am moving this negative charge. I am moving this negative charge towards the positive charge. Okay. So what will happen? Because negative charge will automatically move towards the positive plate, the positive plate will attract this negative charge. So what will happen? The kinetic energy of this charge will increase, and we know that according to the law of the conservation of energy, if kinetic energy will increase, what will happen? The potential energy of this charge will decrease. So it means that at UA it will have high energy. Okay, at point A the potential energy will be larger, whereas at the point B or UB will be lesser. Why? Because when it moves towards the point B, what is happening? This positive plate, let me elaborate more. This positive plate is attracting this negative charge towards itself. So what will happen? The kinetic energy of this charge will increase, and if the kinetic energy will increase, automatically the potential energy will decrease. Okay. So now I have another example for you. So this time let me, so again let me take two spherical charges. Okay, positive and negative. Okay. So what will happen? Again the electric field lines will move, there will be the electric field will establish. Okay. So again I will take an example. So let's say this time what I am doing, I have this negative charge here. Okay. And what I want to do, I want to move this is my point A and this is my point B, and want to move this negative charge from point A towards point B. So my question to you, that what will be the potential energy at A and B? Means whether the potential energy at B will increase or decrease. Okay. Okay, it is a very important question, you have to answer it. Okay. So I will request you all to answer this question in the comment section below. Okay, it will be very useful for you. So in this today's lecture we have studied nothing but a simple topic, word electric potential energy and electric potential energy difference. I hope that you have understand this lecture. If you have understand it, kindly hit the like button and subscribe my channel. If you have any question, you can follow me in the Instagram. I have given my link below. Thank you very much.